Hello everyone, this is Vasant, a ninepointer at IIT Bombay from the Department of Civil Engineering. Today we are going to discuss about statically indeterminate structures. So why this topic is important to us? So see, in real world, most of the civil engineering structures are statically indeterminate because they give extra stability to the structure. For example, if you take a beam which is fixed over here and you take a beam which is fixed, which is known as cantilever beam, one roller support here. Okay, so see, this is statically determinate structure because there are only three reactive forces here. There are three equilibrium equations, so you can find all unknowns by equilibrium equations alone, right? So here there are four reactive forces, but we have only three equilibrium equations. So we can't solve this by equilibrium equations alone. So this is known as statically indeterminate structure. Suppose because of some reason this fixed support is unable to resist movement because of some reason, means it failed in, means the fixed support is failed in resisting movement. Then what this fixed support will become is equivalent to a pin support, right? So then it becomes a pin support and a cantilever beam. Then because of the load acting on the civil engineering structure, any civil engineering structure, this beam, suppose this beam, so it will rotate, right? It will simply rotate. So this is unstable, right? Now let us come to the case of statically indeterminate structure. So suppose this fixed support fails here also, then this will become a pin support and this is a roller support. Then this becomes statically determinate, but this is stable. This is unstable. So now I think you can understand here that statically indeterminate structures are gives more stability to the structure than statically determinate structure. So what is statically indeterminate structure? In statically indeterminate structure, we are unable to solve all unknowns by using equilibrium equations alone. In statically determinate structures, we generally use equilibrium equations, we get all unknowns. But in statically indeterminate structures, we need to have some other equations along with the equilibrium equations to find all unknowns. So those extra two is known as compatibility equations or compatibility conditions. So I already said in first lecture, load has two consequences. One is internal forces and other is deformations. And to study these things, we use three tools mainly. One is equilibrium equation, other is compatibility conditions, and third one is stress strain relationship. We already seen in equilibrium how we use equilibrium equations and how we use stress strain relationship, but we didn't see compatibility equations usage, right? So here is the use of compatibility equations. So if you see this structure, this is fixed over here, this is fixed over here. So see, if it is like this, if it is like this, then also whatever load you may apply, it is stable, right? But you are applying extra support, means you are giving extra support to the structure, means that extra support is making the structure statically indeterminate. So you can guess, like, means you can say whether a structure is statically determinate or indeterminate like this. See, if there is just this fixed support, then also it is stable, but you are giving extra support, means you are giving extra stability. So it is like giving it is like making the structure statically indeterminate. So that is the case. So this is like this, it is fixed here, it is fixed here. So whatever load you may apply in between, but it won't move here, it won't move here. So del AB, if you consider del AB, what is del AB? Del AB will be del B minus del A, right? So what is del B? Del B is 0 because it is fixed. What is del A? Del A is 0 because it is fixed. so is equals to 0. So this will give one equation to us. So this is a compatibility condition. So delta A B is equals to 0 is a compatibility condition. So that is what written here. Changing length of the bar must be compatible with conditions at the support. Right? It must satisfy the conditions given by the supports. Right? So let us solve this problem. So we need to find here reactive forces RA and reactive forces RB, and load P is applied. See, if RB is not there, if this is not there, then there will be just RA and P. Then you will apply equilibrium equation. You will get RA is equals to P. But here, if you apply equilibrium equation, so what is equilibrium equation? Sigma Fy is equals to 0, right? So it will give you RA plus RB minus P is equals to 0. So RA plus RB is equals to P. But there are two unknowns. We need to have one more equation that is given by compatibility condition. What is compatibility condition? Del AB is equals to 0. That means del AC plus del CD, right? So what? So for this we need to know about internal forces in each section. So in this section, if you cut over here, then it will be so we already know that tensile is positive. So away from the cross section is positive. So suppose this is N1, then sigma Fy is equals to 0 will give you RA minus N1 is equals to 0. So N1 is equals to RA, right? So similarly, if you cut over here, you will get this, and this is RB. And so away from the cross section is positive, N2. So you will get N2 is equals to minus RB, right? So del AC, what is del AC? Del AC will be is equals to, in whole section AC, the value of internal load is same. So it is like it is the whole bar AC is in tension with load RA, right? If RA is positive. So what is the formula? PL by EA is the formula. So it is like RA into LAC divided by EAC and AAC, right? So E and A are same for this. E comma A are same. So it is RA. What is LAC? LAC value is A divided by E into A, right? So next, del CV. Del CV is, see here the section is in compression, so it will shorten the bar. So the value will be negative minus RB to LCB divided by ECB into ACB, right? That is equals to minus RB, that is B divided by E into A. So we already know that del AB is equals to del AC plus del CB. So that is equals to RA A divided by EA minus RB B divided by EA equals to 0, right? So RA into A divided by B will be is equals to RB, right? This is one equation. This is second equation we have, and we already have first equation, that is RA plus RB is equals to P, right? So now substitute second equation in equation 1, then you will get RA plus RA A by B is equals to P. So you will get RA into A plus B by B is equals to P. So that will give you RA is equals to PB by A plus B, right? So this is RA. So we already know RA, then RB will be is equals to RA. RA is PB by A plus B into A by B. from equation 2. So we cancel, it will be P A by A plus B is equals to RB, right? So what is A plus B? And A plus B is L, right? You go over here. A is this, B is this, A plus B is the total length of the bar. Total length of the bar is L. So RA will be PB by L. RB will be PA by L. It's the final answer. So as this is a statically indeterminate structure, if you only use equilibrium equations, you are unable to find out the reactive forces RA and RB, right? So you have a need for another tool, so that is compatibility conditions. So here there are two unknowns. So one is equilibrium equations, so other we have compatibility condition. So we have two equations and two unknowns. We solved this, we got the answer. So with this we end today's lecture. In next lecture we are going to solve some problems on statically indeterminate structures to get more, to understand this conceptually and its applications. Until then, take care. Bye bye from 9pointer.